Okay, so what we're going to go over today is the hierarchies. And so we're going to try to get a good understanding of what a hierarchy is, which I'm sure you already know, but we're going to try to understand it within a 3D animation context and possibly how to use it and be able to predict what a change in a hierarchy is going to cause. Okay, so first things first, what we have in Maya we have what we call our nodes, and they're represented by these rectangles. If you go into the hypergraph hierarchy, which we will here in a minute. And you can have multiple of these rectangles, and literally everything that has a transform in Maya will be represented by one of these rectangles in your hypergraph hierarchy. It could also be represented in your outliner. It could also be represented in the hypershader or the multi-lister. There's a bunch of different places it could be. But the one we're going to use the most in this class, partly because I like it the most, is the hypergraph hierarchy editor. And so we have these different rectangles, and by default you'll have 4 here, and even before you create anything in your scene. And one's going to be the top, and one's going to be your side, and one's going to be the front, not necessarily in this order, and one's going to be your for perspective. So these are your cameras. Your cameras in Maya have transforms. A transform node is a node that occupies it describes a certain point in space. And so it has a measure in its translates, and in its rotates, and in its scales. So it has those translate, rotate, scale attributes, or the TRSs. And each of those has an X, Y, and Z. And so, a lot of times in the industry, what will happen is they'll say, well, you need to change your TZ. You need to move TZ 0.5. And so they're saying, move it and translate Z 0.5 units. And so they'll shorten it. I won't do that in class. So I don't really think it saves any time personally, but you get a lot of these guys that are just trying to figure out how to be just a little bit faster. Well, it turns out any object that you can see inside of one of the camera render views is going to have a transform. Now, transforms are not unique to, say, a camera versus a mesh versus a nucleus for a simulation or anything else you can imagine. A curve. The transform is actually the same for all of them. The only unique transform is a joint, and it has an additional set of values called the joint offset, I believe is what they call it, or rotation offset or something like that, which we'll get into later in the class. So the transform decides where an object is in your scene based off the origin. So what is the origin? It's 0, 0, 0, right? In the center of your scene. So if you have the grid showing in Maya, it's going to be the center of that grid. Okay? So the transforms by default are going to be, if they've been moved from the origin, it's going to be the translates are going to show you a offset from the origin. Now, let's say we have our model here. I'm going to draw it down here. Typically, it draws them out. It starts, that was bad. Typically, it draws them out this direction as they're created. And so you'll have, let's say you started working on a model, and this is your model. And so it's going to be out here. And it's going to have a transform node. Now, like I said, everything has a transform if it's occupying 3D space. So how does it know what makes it unique? Well, there's always a shape node that's attached to these transforms. And so in the model, you're going to have it literally just calls it, in this case it would be model, that's bad. Let me decrease my brush size. Model shape. Okay, for your cameras, you'll have a persp shape. Okay, and it doesn't show you those by default. You have to tell it to show you those. Okay, and most of the time you don't want to see them. But they're there, and that's what makes that particular object unique. The shape describes what is going on, and the transform decides where whatever that is happening. So, and by default, when these nodes appear that they're not parented to anything, like there's no hierarchy, like this shape belongs to this model. The model shape belongs to the model. Okay, so that's a little bit of a hierarchy. Parent-child relationship. It appears that the model is not parented to anything at all. Well, that just means it's parented to the scene. And so the scene is its parent. And that's why it belongs to this particular file. Well, what if we have another node, and this is called let's make this one the gun, and it has a gun shape. Oh, bad. Okay, so that says gun shape. Yeah, you're gonna get to witness my very terrible handwriting. So gun belongs to the scene right now, and that's it. And gun shape belongs to gun. That's how it knows where to draw the gun. What if I grab this gun and I make a new hierarchy? So I'll divide this off. And this is our new relationship. We have model, and underneath it we have model shape, and underneath model also we have gun, and then we've got gun shape. Oh, I don't know why I keep putting in S instead of G. Okay. So that's what our new hierarchy would look like. Now, the translate information for gun is based off of its parent, which used to be the scene. So the model, let's say model is not at the origin. And so when we parent gun to the model, and the gun was used to be at the origin, what does the translate information read after we parent it to the model? It's going to change because it has a new parent, and the transform measures the offset to the parent. Okay?